right. So warm up in 102. By now, this should be automatic. I've had plenty of opportunity for you guys to practice your muscle memory. This next section that we're moving into, guys, is going to require everything we've done in the past and kind of like combine it all together. So that's why you need all your senses set and ready for this. Yes? Yes, look at you. All right. So before we continue, turn to your neighbor, let them know what the measures of variation are and what you get for that. What are the measures of variation? Measures of variation. Woo-wee. Let's go. All right, looks like Jaden's got it. Go with Jaden Montes. Measures of variation, what are they? Variance, so that is, I'm just going to write it as this squared, or sometimes we use it with S squared. All right. What else? Dylan. Standard deviation, that's 2. No, so far so good. We need one more. Briseida. Range, that is correct. All right. So far so good. So we need a mean. Show your neighbor your mean. Show your neighbor mean, not that you're mean. You guys are angels. All right. So, mean. Fernando, what'd you get? 18.6. Hands if you got that. All right. So then we need a standard deviation up, 1 down. So first we need the variance. Pass someone, Fernando, for the variance. Joseph. 0.06, looks about right. Standard deviation, pass someone. Peyton. 10.53. 10.53, looks about right, depending if you went with a shortcut or the long way. Somewhere around there. Hands if you got something like that. All right, what'd you get, Daisy? I sense a disturbance in the force. 9.60. Yeah, remember when you do the shortcut or the long way, it's about off by 1, close to 1. So just keep that in mind. But we're going with Peyton's. So this is 10.53, so that's 29.13. Yeah? And 18.6 minus 10.53, that's 8.07. Ooh-wee. Man, the coffee's kicking in. Let's go. Range. What'd you get for the range? Stacy, pass them one. 29. Hands if you got that. Yeah, that is correct. All right. Copy the agenda, please. Warm-up number 102 is done. We're moving into discrete probability distribution. Discrete probability distributions. Your home plate for tonight, make sure you go to exercises 5-1, and you're doing numbers 1 through 8. And once again, exercises, not review exercises. You're doing which ones? Exercises at the end of the lesson. 5-1. Bless you. So far so good, yes? All right, get a Cornell note ready, please, in the meantime. All right, so your home plate once again for tonight, exercises for 5-1 at the end of the lesson, numbers 1 through 8 evens. 1 through 8 evens. All right, so our objective for today, I can define and compute the discrete probability distribution. Discrete probability distribution. So, write that down, please, bottom left. And today we're going to jump straight into this because we've already did a bunch of stuff in the past that's going to come together in one problem. You're going to see that today. You're going to be like, Q, this is cake. I know. It's just a matter of reading it and make sure you understand what you're looking at before you move forward. Simple as that. Okay? So, discrete probability distribution. Discrete probability distribution. So, where have we been? Okay, in the middle of probability, classical, empirical, subjective, we know that. But we're about to embark in variables. So, write this down, variable. What is a variable? In mathematics, we know that a variable is a value that you can assign to a certain symbol, and it changes. And here, the definition, we wrote a letter that is assigned various values, x, y, and z. That's why it's a variable, because you assign what? Various values. Okay? However, we're going to be talking about random variable. A random variable is a variable whose values are determined by chance. Once again, put away those cell phones. I'm going to take them away. Just giving you a heads up. A variable whose values are determined by chance. Random variable. A variable that is determined by chance. All right? I'll give you some time to act like tomatoes so that you're writing that down. So, we are going to focus on random variables, and we're going to be speaking about two types. The first one is known as discrete, and the other one is known as continuous. Write that down, please. One of them is discrete, the other one is continuous. And we're going to clarify today before you leave, hopefully, so like that it's clear. And like I said, now we're going to be dealing more with concepts within concepts instead of just numbers and crunching numbers. That's why these couple next sections are a little bit more funner, if you want to call it. Let's go. Funner. On the corner. All right. So, what is a discrete random variable? What? A finite number possible values or an infinite number of values that can be counted or enumerated. In other words, whenever you are looking at a random variable that is discrete, you can actually know the actual numbers or up to what numbers it goes to. For example, if somebody said, how many students are in Mr. Q's first class or first period? There is an exact number of students, is that correct? That's what we call discrete. Discrete. However, if I was to say, IHS students that just got their driver's license vary in speed as they drive in the county. What do you guys think everybody goes at the speed limit, especially you guys? Some of you? I've seen some of you, okay. I've seen some of you driving fast. And what happens? The velocity varies, is that correct? So there's no exact number that we can pinpoint. That's why that one is known as continuous. Continuous. So a continuous variable is something that changes constantly, that you don't know exactly where to stop it or where it ends. Write that down, please. All right, thanks for sending that in. All right, so any questions with discrete and continuous? All right, so we said discrete, we said Mr. Q's first period class, the number of students. That's discrete because it's an exact number. Continuous is the speed in which high school students drive in Imperial. Right? Because I see some of you driving, you guys don't stick to the speed limit and so on and so forth. So, before we move on, make up an example of discrete and make up an example of continuous. Talk it over your neighbors. Give them an example of what discrete is and what continuous is. You don't have to write it down, just make up an example in your noodle. What is discrete? What is continuous? Like Jordan, I'm going to get that as a block it, grab it, and fall with a rebound. Okay. All right, let's see who went last. Was it Peyton? Pass someone, Peyton. Chelsea, an example of discrete. What is it? A sports team, because it has so many players that can play at a time. Oh, that's good. How about continuous? Pass someone, Chelsea. Who? Joseph. What is it? A slot machine, because it varies when it's going to stop and give you the winning numbers. Yes? Pretty much? Does that make sense? Yeah? All right. Let's move on. Look up, please. So let's talk about discrete. In discrete, we're going to be talking about something that we call discrete probability distribution. Stop writing, look up. Discrete probability distribution. Even though it looks like a long term, it's something very simple. What is it, Mr. Q? It's this. It's a table. Here it goes again. What is discrete probability distribution? It's a table where you gather all the information given and set up in an organized way. For example, here's an example that I gave you. Here's a table. This is a discrete probability distribution. So let's say they gave us a problem and you wanted to fill this in. Well, what goes up here? Up here go numbers. And I'm trying to be as clear as possible so that you understand what this is without getting too confused. What kind of numbers? These are whole numbers. However, the probability section is in decimals, or, that is correct, fractions. That's what discrete probability distribution looks like. Students, discrete probability distribution, students. It's a long term, but it means a table. Okay? So with that said, start with the first one. It reads, the Baseball World Series is played by the winner of the National League and the American League. The first team to win 4 wins the World Series, the World Series if they win 4. And in other words, the series will consist of 4 to 7 games, depending on individual victories. The data shown consists of 40 World Series events. The number of games played in each series is represented by the X. Find the probability P of X for each X. Construct a probability distribution. Question. Look up to the screen. Tell your neighbor what this means. What does that mean? What does that mean, Fernando? To make a table. Big term, but that's all it says. And once again, it has to look something like that. Yes? So first of all, write on your paper, example Q. Don't copy all the verbiage. I want you to copy the table, and then we're going to make a probability distribution on the side. I'll give you some time to copy that table, please. So you copy the table, and we're going to make a probability distribution. Tell your neighbor, what are you going to label the top, and what are you going to label the bottom? What are you going to label the top, and what are you going to label the bottom of the probability distribution? What shall we label the top? Let me go back to the previous one. X, or the bottom is P of X. So let's label this one X and this one P of X. All right, let's label what each label stands for. What does X stand for? Tell your neighbor. What shall we write here? should we write there, Areli? Games played, that is correct. Games played, label that. And the bottom P of X is just the probability. Probability. All right, so let's start with X. Do they give us the X values already? Yeah, they're right here, so let's write them out. 4, 5, 6, and 7. All right, so what did we say we write on the bottom? These are the whole numbers. What do we write on the bottom? Fractions or decimals, is that correct? So, here we go. Let me write the first one. The probability of 4 games played. How would I write that? Think about it. Given this information, even if you didn't know what it was saying. So you never what you would write. Let's see. Diego. 40 on the denominator, that is correct. How many games? 8. 8 over 40, that is correct. Change that into decimal, please. What is that? Simplify this as 1/5, which is point what? 2, that is correct, or 0.20. So now that I showed you how to fill in the probability portion, and this sounds familiar, doesn't it? Doesn't this go back to what we did? Oh, slide, my goodness. To the beginning of the school year, right? All right, so fill in the rest, please. I'll give you some time. Go. Give me a second. So once again, once we get the sum of all these to equal to 1, we know it's a probability distribution. They asked for the graph of the data. So we made here a quadrant, X, probability over here, and then we just started plotting these. There they are, and then we just decided to make a bar graph. There it is. Now, some of you might want to do the connecting thing and so on and so forth. That's fine. Okay, so that's pretty much the home plate. However, what if they give you something like this? Write that one down, example 1. Construct a probability distribution for rolling a single die. All right? So what do we do right away after you write that down? Our probability distribution, we started off with what? X, and what else? P of X. Okay. So, tell your neighbor what to write on top for our rolling a single die. What shall go on top? Looks like we got it, Caleb, right? So tell me what to write on top. Yes. We got X, but what goes on top for a rolling a die? Bam! One what? Oh, 1 through 6. 2, 3, 4, 5, 6. All right. Tell your neighbor the probability for each of those. Dylan, go. And once again, how do we check to make sure this is correct, everyone? The sum has to be what? 1. 1/6 plus 1/6 all the way through, that is what? 1. From 1 to 5, how comfortable are you with this? You got it, right? Okay, send me your notes, please. Woo-wee. We're flying through this, let's go. Write this one down, example 2. It says, construct a probability distribution for sample space for tossing 3 coins and getting heads. You're like, oh snap. Yeah, this is a little bit different. So copy this problem really quick, and then we're going to work this one through. All right? It says, construct a probability distribution for a sample space of tossing 3 coins and getting heads. So, on the right side, before we construct our probability distribution, we need to know numbers, right? Because the dice was easy because it's 1 out of 6. We got that. But now we have 3 coins. So label over here, coin 1, coin 2, and coin 3. So, let's say the first coin falls heads, the second one heads, and the third one heads. What's the next option? Heads, what? Heads, tails. Next, heads, tails, tails. And the next one, heads, tail, heads. Next, tails, heads, heads. Oh, you want to go tails, tails, tails? Okay. We'll start with tails, tails, tails. Okay. Tails, tails, tails. And then tail, head, tail. And what else? Heads, heads. Are we done? Yeah, right? Because the first coin, there it is, and all the other combinations. So how many total combinations, guys? Let's see. 1, 2, 3, 4, 5, 6, 7, 8. Okay. So, here goes a question. Looking at those combinations, it says here, for the sample space of 3 coins getting heads. All right. So what is one option? Is there a possibility that we can toss all 3 coins and not get any heads? All right. So then on our distribution, we start with what? 0. Because there's no way that we're going to get from there. What would be the next one? 1. Because 1 comes up right here. What's another option? 2. 2 heads. What is the total number of heads that can come up in 3 coins? 3. There it is. All right. So, look at the combinations. What is the probability of not getting any of them to be heads? 1/8. That is correct. Because if you notice here, which is one that does not have any combination of heads? This one right here. Tails, tails, tails. All right, so 1 out of the 8, so that's 1/8, and that's how much in decimal form? Point what? 0.25? 0.125. 0.125. Okay. All right. How about only one coin being heads out of all the 3? How many? And so here's 1 right here. 2, 3. Is that correct? All right. So it's 3 out of what? 3 out of 8. That is correct. And in decimal form, what is that? What is it? 0.375. All right, fill in the other ones, please. Please say that. 3/8, and that one is 0.375. All right. And the last one, Billy. 1 out of 8, and that is 0.125. Check your math. Oh, is that sum equal to 1? Yes? All right, from 1 to 5, I'll come toward you with this. We good? All right, send me your notes, please. Here they go. All right, so I think we got it, and that's how the home fleet's going to go. But just to clarify, these next slides are going to go fast. So I want you to look at the slide, the information, and just write me on the screen your answer. And make sure you share it with your neighbor to make sure they understand what you're looking at. Here goes the first one. It reads, is the following probability distribution? Elaborate. Tell your neighbor. So on the screen, either write Y or N and elaborate to your neighbor. Is that a probability distribution? Is that a probability distribution? Jaden, Wilson, why not? It doesn't add up to 13, that is correct. Make sure that all of these on the denominator, all of these add up to 13/13, which equals to what? 1, that is correct. Let's go. Next one. Is the following variable discrete or continuous? The speed of a jet airplane, either write D or C on the screen, D or C, and tell your neighbor why you selected that. Speed of a jet airplane. All right, looks like Areli's got it. Areli, what do you think? Continuous, why? It can vary. It goes from slow, it starts going upward, and then it goes down, and so on and so forth. That is correct. All right, next one. The number of books at the IHS library. Tell your neighbor and write the letter. All right. Alexa. Discrete. Why discrete? There's only a certain amount, and the librarian goes and checks every one. And for those of you that owe books, you guys need to start putting those back already. You know what I'm saying? Or else you won't go to grad night. Woo-wee. Next one. The number of people who play lotto. Number of people who play lotto. Everyone. Everyone. Continuous. Do we know how many people play the lotto? No, it varies. All right? And last but not least, it reads, construct a probability distribution for the data shown on the screen. You have exactly 4 minutes, and let me send you the screen so you can send that in. For those that are following on YouTube, use this as practice, and if you have the book, go get some practice some more. I'll stop the video right there.